YouTube channel. This is Jonathan Goldfish. Be sure to like, share, and subscribe to my YouTube channel. Thank you for your support. For this video today, we are going to discuss the exercises for Chapter 2, Functions. Alright, let's take a look at the first questions. So this is the first question from the Pure Mathematics 1 9709 course book. Okay, the question from the course book. And this question wants you to this question asks you to state whether it is a one-to-one or many-to-one for each part below. Okay, and which of these graphs represent functions. Alright, so let's recall what is function. Okay, so the function defines is a function that has a relation of 1 to 1, maybe I use number, 1 to 1 and many to 1 relationship. Okay, many to 1 relation. Okay, only these two relations are called function. Okay, and let's take a look at the first part, which is the part A, y equals to 2x minus 3. Okay, ask yourself, y equals to 2x minus 3 for x subsets to all real numbers. Is it a function? The answer is yes. Okay, why it is a function? Okay, different objects have the different images. Okay, and it is a linear function graph. Alright, so when you draw a linear graph in the Cartesian plane, it is obviously one-to-one relation. Okay, so it is a one-to-one function. Okay, so that's the short answer for the part A. Let's move on to the part B. Y equals to x squared minus 3 for x subsets to all real numbers. Okay, so is it a function? Yes, because from x to y. Okay, means that two objects have the same image. Okay, so it is a function. It is a quadratic function. Well, is it a what type of the function for this quadratic function? Okay, you see there's an x which is positive and minus 3 with your y-intercept, so means that your graph should look like this. Okay, about this position. Okay, and how to test whether it has a one-to-one or many-to-one relation? We can use vertical line test. Okay, so you draw any vertical line test in any position, so you will see that this vertical line only intersects one point with the graph. Okay, so what does this indicate? It indicates that it is a one-to-one function. Alright, so this quadratic is a function and it is a many to one function. Okay, why it is a many to one function? Because two objects have the same image. Alright, let's say fundamentally when you let y equal to 0, and you will solve x as a two solutions, two roots. So means that it is a many-to-one function. Why it is a one-to-one function? As I said before, because each object has different image. Okay, each object has their particular image. Alright, so let's take a look at the C. Okay, C is a cubic function. Y equals to 2x cubed minus 1 for all real numbers. For x is all real numbers. So it is obviously a function because you have the x in the end you have one image. Alright, so you can see that these two relations has only one image, okay, for one or many objects. Okay, I mean the one or many domains to get only one range at a certain range. Alright, so what is the type of the function, the relation? It is a one-to-one. Sorry, it is one-to-one. Why? As you can see that this cubic function raises to the highest power of 3, whereas for the quadratic raises to the power of 2. Okay? So means that fundamentally it is a one-to-one function. Alright? Okay, let's say here is your cubic function, and when you are doing the like this, okay, when you are doing the vertical line test, so always it has 3 solutions. Alright, because for this cubic function, so it is a one-to-one function, one-to-one relation function. Okay, so let's take a look at the D. Y equals to 2 power x. Okay, it is an exponential function. Okay, just that the base is not e, it's 2. Alright, so it is not considered as a exponential function. Instead, it is a power function. Alright, so it is obviously a function because domain, okay, this function fx or y that equals to function of y equals to function of x, where function of x is equal to 2 power x. Okay, so it is a function. And okay, for an exponential function, it is always a positive function graph. Okay, so this one you will learn in your A2 chapter 2, which is the exponential and logarithmic function. Okay, and you will see that if you're doing the horizontal line test or vertical line test, each domain has different image. Alright, so it is a one-to-one function. Okay, oh shit. Okay, so we have done the 4 parts A, B, C, D. What about let's proceed to the E, part E. Okay, E is y equals to 10 over x for x all real numbers, but x is always positive. Okay, so it is a reciprocal function. Alright, so obviously it is a function because y equals to function of x. Alright, and for the reciprocal graph, here is a example of the reciprocal graph. Okay, generally your graph will looks like this. Okay, so if you're doing the vertical line test, so this line only intersects one point with the graph as well as another side. Okay, so let me repeat again. When you are doing the vertical line test, you draw any line that only intersects one point for the positive quadrant and the third quadrant. Okay, so means that this reciprocal function is a one-to-one function. Okay, okay, let's move on to F. Let me erase it away. F. Okay, F is still a quadratic function. Y equals to 3x squared plus 4 for x are all real numbers and x is greater or equal to 0. Okay, so it is a function, obviously, and for this quadratic function, it is obvious. You need to sketch the graph first, just before you interpret whether it is a one-to-one or many-to-one function. All right. So your graph will look like this. So what you can observe? You can observe that it does not touch the x-axis. Means that the discriminant for this quadratic function is a negative. Alright? So means that this quadratic function has no real roots. So if you're doing the vertical line test, you can see that this vertical line only intersects one point with the graph. So means that this is a one-to-one function. Okay? And you will doubt that why does the answer for B is many to one function compared to the F is one-to-one function? This is because that this function has real roots, whereas for this function does not have real roots. Okay? Compared to the graph over here. Can you observe it? Huh. Okay? So I hope that I've overcome your doubt already. Okay? So let's move on to the question part G. Y equals to square root of x for x all subsets all real numbers and x is greater or equal to 0. Yeah, this is correct because you can't in the square root function you can't let your x become a negative, okay, or else it won't be get the real solutions. All right. Okay, in order for the x to be real, you must let this become positive or 0. Okay, at least 0. If you solve the square root of -1 or negative square root of -2, this one you will get I. This one you will get square root of 2i. Okay, so it is not a real numbers but complex numbers. All right. So yeah, this is a function. Okay, what is the type of function for the y equals to square root of x? Of course, it is a one-to-one. Why? Because when you sketch the square root function, okay, basically is you treat your y-axis as your x-axis, you treat your x-axis as your y-axis. Okay. Next you can invert it you can rotate in this way. So now here is your x-axis and here is the y-axis. It is basically y squared equals to x. Then you sketch it in this way. Just that you need to sacrifice away the negative range when you rotate back to its original position. Okay, so this is how does the square root graph look like in the Cartesian plane. Alright, so what you can observe that when you're doing the vertical line test, it only intersects one point with the graph. Okay, so this is how do we interpret the type of the function by using the vertical line test. Got it? So let's take a look at the h. Okay, so h is the final part, which is the this part is different. It gives y squared equals to 4x for x all real numbers. Okay, is it a function? Many students will say that will answer that it is a function. Okay, initially. In fact, The answer is no. Okay? It is not a function. It is not a function. Why? Because your y is not equal to function of x. Okay? So you want to let it become the function, you need to say that y equals to function of x. Okay? In order to say it is a function. Alright? So, if it is not a function, and means that this this equation is also not one, neither one to one nor many to one relation. Okay? So that's the end of the discussion for this first question. Alright? Okay, move on to question 2. So question 2 is about the transformation of the function of the graphs. Okay? So this question is also extracted from the course book. So let's take a look at the question 2. Figure above shows the graph of y equals to fx not gx. Please make the correction. Draw the graphs of the following. For the first part, y equals to fx minus 2. For the second part, y equals to the function to the x minus 3. Third part is y equals to f, the function of 3x. Okay? So let's solve the first part. Alright, I may use the different color to represent the answer. Alright? So, you see, y equals to fx minus 2. What does minus 2 mean? It means the entire graph only moves down by 2 units. Okay? So you must check your coordinates. Each coordinates that intersects the graph move down by 2 units. Means that the slopeness, okay, the size won't change. So for this, you move down 2. For this, you move down 2. For this, you move down 2, and here as well as here. So you can see that the gradient doesn't change. Okay? So, yeah. Wait a second. Oh yeah, there's another coordinate. Okay? So this is how you draw the new graphs that is transformed from the original function. Okay? So here is your y equals to fx minus 2. There you go. Okay, let's move on to the second part. Okay, this time I will use the light blue one. Okay, so for the second part, it wants you to sketch the y equals to f, the function of x minus 3. Okay, so x minus 3 means that each x coordinate moves 3 to the right hand side. Okay, always remember that the vertical transformation is totally opposite than the horizontal transformation. Got it? So this one moves 3 unit starting from here, 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 and here. Alright? 1, 2, 3. Okay, over here. Over here. Okay. 1, 2, 3. Okay. So for the second part, it only involves the translation. Okay. And you just move it. So your graph will look like this for the second part, which is the y equals to fx minus 3. There you go. Okay, let's change the different color to do the third part. Y equals to function of 3x. So what can you see that? Um, it is a stretch parallel to the x-axis, but with scale factor of 1 over 3. Okay, so it is always opposite from the vertical transformation for the stretching. Okay, involving the stretching of the graphs. Okay, so that means, let's say here is your 2 0 2, correct? Here is your 0 2, and you will multiply the x coordinate by 1 over 3, or divided by 3 for x coordinate. Okay, since here is a 0, this one you so for this coordinate remains unchanged. Okay, so for this side is negative 2, will change to negative 2 over 3. Okay, negative 2 over 3 is approximate about negative 0.6667. Okay, so let me approximate my new position over here. Sorry. Meanwhile, for the another side is 2, negative 2 over 3 over here. Okay, draw the lines. So you will see that after the transformation of f function of 3x, your graph will look like this. So here is a y equals to f 3x. Okay, that's the answer. Okay, let's move on to the question 3. Okay, so question 3 is also involves the transformation of the graph. Okay, so figure above shows the graph of the y equals to gx. Draw the graphs of the following. For the first part is y equals to gx plus 3. For the second part is y equals to function g to the x plus 2. And for the third part is y equals to function g of the 2x. Okay, let's take a look at the first part. So this time I will use the different color. Okay, maybe this one. Yeah, it almost matches. Okay, so here is your function gx. You need to add by 3. Okay, this is the translation by moving up 3 units. Okay, vertical transformation by moving up by 3 units for each y coordinates. Okay, so here is your 2. Let's say for this point is 2 1. You increase the coordinate by 3. Alright, so 1 2 3 over here. Meanwhile, for this, increase by 3 as well. Next, you sketch the graph. Okay, you will see that its slopeness does not change. Okay, so that's the answer for the y equals to gx plus 3. So let's take a look at the second part. Let me change the color of the pen. This time orange. Yeah, almost. Okay, so x plus 2, what does it mean? It means that each x coordinate moves to the left by 2 units. Okay, so starting from here, we'll move to the left. So 1, 2. So here is your new your transform coordinate. Okay, as well as here and here. Next, you draw a line, and that's the new transformated graph. Okay, there you go. And let's take a look at the third part. This time we use this color. Y equals to g function g to the 2x. Okay, means that you need to divide each x coordinate by 2. Alright, so let's say here is a 2, here is your 2, 1, correct? So you need to divide this by 2. So this you will get 1. Okay, for this is 3, negative 2. So it its new transformated coordinate is 1.5, 2. Okay, because 3 over 2 is 1.5. So graph would look like this. Okay, and for this one is 5, 3. Means that its new coordinate is 2.53 because 5 over 2 is 2.5. Okay, so yeah, here is your new transformated graph. Y equals to g to x. Okay, got it? Okay, let's move on to the question 4. Sketch the curve of y equals to negative square root of x. Okay, so what are you going to do for this question? Okay, to sketch a square root function graph, what you can observe that there is a negative sign. What does it indicate? For the entire ff function, you need to reflect. Okay, so means that an ordinary square root function of x has transformed into negative square root of x through translation. Not translation, sorry, it's reflection on the x-axis. Okay, reflection of this square root graph on x-axis. Okay, so here is a center line for the reflection. Okay, so your graph should look like this. Okay, done. So let's take a look at the second part. Describe fully a transformation that transforms the curve y equals to negative square root of x to the curve y equals to 5 minus square root of x. Okay, so what's the difference between the original to the new one? You will see that there is a positive 5 in this new curve, in the new curve mentioned over here. So you will only have a translation since you move the negative square root graphs upwards through 5 units. Okay, So you should say, okay, so maybe I will rewrite again. So you just state your answer as translation 05. That's all. Okay, this is the best answer. Short, short but neat. Okay. Okay, let's move on to the third part. The curve y equals to negative square root of x is stretched by a scale factor of 2, parallel to the x-axis. Okay, stretch parallel to the x-axis with a scale factor of 2. State the equation of the new curve after it has been stretched. Okay, you can see that this part transforms the curve through stretch parallel to the x-axis, okay, with a scale factor of 2. Okay, scale factor of 2 means the x must be replaced by 1 over 2x, okay, because the the transformation of the stretching involved in the x direction is always opposite, okay, opposite from the vertical stretching. Okay, so you only state that y equals to negative square root of half x. Okay, just replace x, substitute x by your half x. That's all. Or you can state y equals negative square root of x over 2. It's also acceptable. Okay. Anyway, these two forms are equal. All right. So that's the end of the discussion for this question. Okay, let's move on to the question 5. Sketch the curve of y equals to 1 over x squared. Okay, so this is a reciprocal graph. Just that the reciprocal function is x squared. Okay, which is the quadratic, but this time is reciprocal of the quadratic. All right. So let's sketch the graph. All right. So did you heard about what is VA? Okay, just like what I mentioned in the previous video, it means asymptote. A represents asymptote. Okay, so usually for the asymptotes, you need to say this graph doesn't touch it. Okay, in the vertical direction and horizontal one. Okay, so we have VA and HA. So what is VA? VA is a vertical asymptote. So what is vertical asymptote? Okay, it is a vertical line that positions. It depends on the x position, the position of the x coordinate. Okay, so it means that to find the vertical asymptote, what things in order to let this function to be indefinite. Okay, so as you know that you can't divide 1 by 0. Okay, because if you divide by 0, you will get infinite. That is indefinite. We don't know what is infinite. What is the value of infinite, right? So equate the denominator as 0 to get it. So that means your vertical asymptote is x equals to 0. Okay, for the horizontal asymptote, you need to learn what is the limits as the x goes to infinity for 1 over x squared. Okay, this one you will learn in the further maths chapter 2. Okay, which is the rational functions and graphs. And as this, I may evaluate this as y equals to 0. Okay, means that your asymptote is x equals to 0, x equals to 0, and y equals to 0. Okay, so this rational graph, I will teach in another video for the fundamental topics. Alright, so this is how you sketch this reciprocal graph. Okay, there you go. Here is a y equals to 1 over x squared. So as you can see that x squared, no matter x is always real number, and x can be any value, just that x need to be real number. It is also a positive reciprocal function. So means that there is no negative range for this reciprocal function. Okay? So that's all for this first part. So let's take a look at the second part. The curve y equals to 1 over x squared is translated by 3 units in the negative x direction. State the equation of the curve after it has been translated. So please highlight translated by 3 units in the negative direction. So for the negative x direction, that means you need to substitute away your domain x as x plus 3, because negative x direction by 3 units is plus 3. Okay, it's always opposite from the vertical translation. So therefore, you just only to state that y, the answer for the part 2 is y equals to 1 over x plus 3 squared. That's all. Alright? Okay, let's take a look at the third part. The curve y equals to 1 over x squared is stretched parallel to the y-axis with the scale factor of 4. And as a result, the point 1, 1 is transformed to the point Q. And the question wants you to state the coordinates of the Q. Alright. So let's start from y equals to 1 over x squared. So what is the transformation? It is a stretching, right? Stretch parallel to the y-axis with scale factor 4. Means that you just only to multiply the entire fx by 4. Okay? So this is the new equation, right? Okay? This is the new equation, new transformated equation from the original curve. And given that there's a point P, 1, 1. Okay, that is transformed to point Q. So you can see that only y is changed. You see, stretch parallel to the y-axis scale factor of 4 means that every y coordinates from the original curve will multiplied by 4. So therefore, your coordinate of Q is 1, 4. Okay, that's the answer for the third part. Okay, let's move on to the question 6. So let's take a look at the first part. The curve y equals to x squared is translated 2 units in positive x direction. Find the equation of the curve after it has been translated. So you see positive x directions translated 2 units in positive x direction means that you just substitute x as negative 2. Alright? So why? I will not repeat this reason again. Okay? Please please take a look back what you learned from my video. Okay? From the lecture. So the answer for the first part is x minus 2 bracket squared. Okay? That's the answer. For the second part, the curve y equals to x cubed plus 4 is reflected in the x-axis. Okay? Find the equation of the curve after it has been reflected. Okay? So in the graph, reflected in the x-axis means that your y, your function fx, is going to be reflected by multiplied by negative sign. Or you can say that each term changes its sign. Okay? So here is your new transformated graph. Okay? your answer should be negative x cubed plus 4. There you go. Okay? Okay, let's move on to the question 7. Describe the sequence of transformations that maps y equals to fx to each of the following functions. Okay, so means that there is not only a transformation, but with multiple transformations. Okay, so let's take a look at the part A, which is the half fx plus 3. Okay, so means that the sequence of transformation or the order of transformation is crucial for this question. Okay, and you can see that there's a half and plus 3. Okay, so let's say in an ordinary fx, I multiply by half. What does it mean? There is a stretch parallel to y-axis with scale factor of half. Okay, so you must label as first order. Okay, you must take it like this in order for the examiner to give you the marks. Okay, if not examiner won't understand what do you answer it. Okay, what is the answer that you want to pretend. Okay, and the second order is translation. Okay, because you see there's a plus 3, so you can say that there's a translation 0 3 because there's a vertical translation. Okay, or some of you will say you can factorize this half fx 6, and there's an alternative answer. You can say that translation 0 6 and stretch parallel to y-axis with scale factor of half. Yes, it is also acceptable. Okay, but usually I will if I'm the candidates, I will answer this one. Okay, because I'm the former candidates of the A levels. All right, so I have to erase away the answer for this part A for me to leave some space for the following parts, part B, C, D. Okay, so let me erase it away first. Part B, y equals to negative fx plus 2. Okay, so I will give you the example of the answers. All right, if you have alternative answer, you can comment in the you can leave your comment in the description below. Yeah, you can leave your comment in the comment section below. Okay, and then you can let me verify your answer. Okay, so you can see that there's a negative and also the plus 2. All right, for me, I would say I don't want to see this first. Let's focus on this. So you can see that there's a reflection of the fx entire function, which is in the x-axis. Okay, why is it in the x-axis? Because you need to reflect the original y into negative. Let's say here is your 3, you will reflect into negative 3. Okay, so this is the old and this is the new. So this coordinate undergoes reflection in the x-axis because the x-axis is the center of the line of the reflection. Okay, next you have translation 0 2. Okay? When the question mentions sequence of transformations, this keyword, you need to put the order. Okay? 1, 2. Just like follow my way. You sure will obtain this mark. Okay? I hope you understand what am I doing here. Okay? So let's take a look at the C. C is the y equals to f 2x minus 6. So what is the transformations? Okay? So first thing first, I don't want to I don't want to see this. Maybe I can focus on this. So you can see that there's a stretch parallel to x-axis with scale factor of half. Okay? Because it involves the stretch in the x direction. Okay? Next, we have minus 6 means that there's an translation 6 0. Okay? I know for this part you might have your alternative answers, but just if you have alternative answer, just comment in the comment section below of this video. All right, so let's take a look at D. Okay, for the part D is y equals to 2fx minus 8, and I will not discuss this too long because this part is similar as the B and A. Okay, I will just write whatever I know. So there's a stretch parallel to y-axis with scale factor of 2 and translation, and next followed by translation of 0, negative 8. Okay? Alright, let's move on to the next question. Question 8. So question 8 also involves the sequence of transformations. Okay, describe the sequence of transformations that maps the curve y equals to x cubed onto the curve y equals to half the cube of x plus 5. Okay, so let's do part A. Given that there is an equation of y equals to x cubed, alright, it transforms into the curve of the y equals to half x plus 5 cube. Okay, so what you can observe that there's a half over here and there's a plus 5. Okay, so means that no matter how you sort the sequence of the transformations, in the end you will get the same transformated graphs. I mean the transformated curve. Okay, so for my suggested answer, that is the first you describe the half first, which is the stretch parallel to y-axis, because you need to multiply half to the entire function f, function to the x, with scale factor of half. Next, you have translation. Okay, this translation involves the horizontal translation. Plus 5 means you have the translation of negative 5, 0. Okay, so if you swap the sequence, in the end you will get the same curve. Okay, the same transformator curve. Because since the half didn't expand inside this cubic function. Okay? Okay? So any problem? If no, if you have any problem, you can comment. You can comment your doubts in your comment section below. Okay. I need to clear this away for me to do part B. I mean the rest of the parts in this question. Okay. So given there's a for part B, given there's a curve y equals to x cubed, to transform it into this new curve. Okay, I need to write this first. So for this question, it involves sequence transformation that's right, but it is with the full exact function. Okay, it tells you the function, the exact function f, okay, that involves the transformation. Just that you need to consider the sequence. All right. So for this part B, the sequence of transformation, I mean the order of the transformation is crucial from this question. Okay. So how to describe this transformation? First, you can first you can factorize the negative out. Okay. Next, you can factorize the half. So you will have, sorry, here is a positive, plus 4. Okay. So you can describe the transformation as translation -1 4. Second, you have stretch parallel to y-axis with scale factor of half. Finally, you have reflection in the x-axis because you need to negate the entire function f, right? Function to the x. Okay, that means the y coordinate each y coordinate reflects about the x-axis. Okay, I know for this part you have alternative answer, but I'm not going to discuss I'm not going to give the alternative answer over here. If you have alternative answer, you may comment your alternative answer in the comment section below. Okay. So I may erase away the B for me to do part C. So part C is different from A and B. Given that there's a y equals to cube root of x, okay, it transforms this into the curve of y equals to -2 square root of 3 x minus 3 and plus 4. Alright, so I will give you the alternative answer. I mean my suggested answer. So you can see that there's a -2, there's a -3 and 4. Alright, so what I can do is okay, the first is reflection in the x-axis. Next is stretch parallel to y-axis with scale factor of 2. Okay, so you have the reflection, you have a stretching. Now finally, eventually you have translation. Okay, so you can write the third sequence of the transformation, which is the translation of 3 4. Okay, there you go. So here is my suggested answer following these transformations. Of course, you need to consider the sequence. Okay, as I said, comment your alternative answer for each part in the comment section below. Okay, so if you don't have any doubts, let's proceed to the past questions, because since this is the last questions from the course book in this chapter. All right. All right, let's move on to the next question. This from here, this is the passive questions all the way to the end of this exercise in chapter 2 function. Okay, let's take a look at the question 9. So this is the passive questions that is from the 9709 October November 2006 question 10 paper 1. Okay, the function f is defined by f maps to x to get the x squared minus 3x for x subsets to real numbers. Okay, there's a mistake of the notation of the real numbers. Okay, so for the second part, express fx in the form of x minus a bracket square minus b, and it also asks you to state the values of a and b. Okay, so what are you going to do? So this is basically completing the square, right? So given that the fx equals to x squared minus 3x. Okay, next you carry out the completing the square. So how does the completing the square perform? I won't repeat this again. All right. So it's basically b over 2. All right. Okay. Over here. And then you can see that you will have a completing the square. Okay. So I have x minus 3 over 2. And then meanwhile for this term, you will have negative 9 over 4. Okay, so this is the expression. This is the expression of the fx in the vertex form. And where your a is 3 over 2 and b is your 9 over 4. Okay, so for the third part, write the range of f. Okay, so first you need to sketch the quadratic graph first, just before you state the range of the function f. Okay, so you can see that there's a transformation x minus 3 over 2, that means, and also negative 9 over 4. So it means that the quadratic, the parabola graphs moves us to the right horizontally by 3 over 2 units and negative 9 over 4 downwards. Okay, so here is your approximate coordinate. I mean the approximate coordinate of the turning points. All right. And then the question wants you to state the range, where this is your 3 over 2 and negative 9 over 4 as your turning point. So what's the range? Okay, the range means the function of the domain. So here is your range of the quadratic function. Okay, so starting from here, that is your range of the fx. So you may state the range of f, that is fx is greater or equal to 9 over 4. That's all. Okay. Okay. So take a look at the fourth question. State with a reason whether f has an inverse. Okay. So the question wants you to determine whether the function f has inverse or not. So if you're doing a horizontal line test, okay, because if you want to test whether there's an inverse function, you have to carry out the vertical line test. There's a horizontal line test. Okay, so you simply draw a horizontal line, and then you slide upwards and downwards. You will see that mostly this horizontal line intersects 2 points with the graph. So means that there is a there is a there is many to one relation because doing a vertical line test, a horizontal line test, sorry, horizontal line intersects 2 points with the graph, with the function f. Okay, but this pure maths is not an essay question, but I just write my suggested answer with the clear reasons. Okay, clear and neat reasons. So therefore f does not have inverse. Okay, so that's the end of the discussion for this question 9. All right. All right, let's move on to the next question. So starting from this question, this is a challenging question, but all from past year papers. Okay, so let's take a look at the question 10. This is a question from 9709, May June 2010, paper 11, question 9. Okay, the function f is defined as f maps to x to get 2x squared minus 12x plus 7 for x subsets to real numbers. Express fx in the form of vertex form. Okay, so as I mentioned in the previous question, just use the completing the square. Okay, so I may not repeat how does the completing the square perform. Okay, so it is literally let the coefficient x squared become 1, add minus b over 2 bracket square, and then simplify. That's all. Okay, so you don't have to no doubts in performing the completing the square. Okay, okay, so here's your answer. So let's take a look at the second. What is the range of the f? Okay, actually the range of the f is greater than or equal to negative 11, since your a is positive, means that this quadratic graph has minimum point. Okay, where the minimum point is 3, negative 11, and the range of the f of course is greater or equal to negative 11. Okay, so let's take a look at the third part. Find the set of values of x for which fx is less than 21. So you have to let the fx less than 21, substitute your fx as this one. Okay, substitute the vertex form for you to for the convenience for you to solve for the set of values of x. Okay, so move to the other side. So I have x cubed square, simplify it. All right, So you can see that there's a less than 16, right? So if you let x minus 3 square equals to 16, you will have x equals to x equals to 7 and x equals to -1. Okay? Instead, I may perform in this way. So I have -4 and to 4. Okay, add 3 to the all sides, so we get -1, x, and 7. So this is the set of values of x for which fx is less than 21. Okay, let's take a look at the fourth part. Okay, fourth part, there's a function g is defined as g maps to x to get 2x plus k for x subsets to all real numbers. Okay, so find the value of the constant k for which the equation g of x equals to 0 has two roots. So first thing, you need to find what is g of x. Okay, so g of x is a composite function, as you know. Okay, so substitute your fx as 2x squared -12 plus 7. But instead I will just directly place as the 2x minus 3 plus 11. Okay, you can do it this way. And then you put inside the function of this function of g from the function f. I think to find the discriminant, you need to substitute the general form better. Okay. Expand and simplify it. Okay, here is your gfx, but in terms of x and k. Next, you equate the gfx equals to 0 first. So we see that there's a 4x squared minus 24x plus 14 plus k equals to 0. Hence find the constant k for which this equation has two equal roots. What does it mean? Okay, it means that its discriminant equals to 0. Okay, because since gfx, when you function your g to the fx, you will still get a quadratic function. Okay, so identify your a, b, c, and then equate the discriminant to 0. All right. And then now you solve your k. The answer of k is 22. You may check by yourself and see. Okay, so that's the end of the discussion for this question 10, that is past year questions. Alright, let's move on to the next challenging question. This is also your past year questions, 9709, October, November 2010, paper 1-3, question 3. So given that there's a functions f and g are defined for x subsets of all real numbers, which f is defined as f maps to x is 2x plus 3. For g is defined as x squared minus 2x. Express gfx, but in the form of vertex form, where a, b, c are constants. Okay, as long this these constants are real numbers. Okay, that's the fact. So first thing first, you need to find what is g of x. Okay, fx is 2x plus 3, where meanwhile gx equals to x squared minus 2x. Okay, so substitute your fx first and then gx. Okay, your gx is 2x plus 3 square minus 2x. So don't tell me this is the vertex form. If you leave your answer in this form, I can tell you that is the wrong one. Okay? For pure math student, you shouldn't make this careless mistake. Okay? So you have to expand into the general form just before you convert to vertex form. Okay? What is vertex form? Vertex form means there is only x inside the square and the rest of outside must be a constant. Okay? So the only way you do is expand it. Okay? So this is how you expand it into the general form just before you convert to vertex form. Okay? So in the chapter 1, you should learn about this. Okay, I'm not going to repeat this too much because technically completing the square is crucial, very crucial in answering the related questions. Okay, closely related questions, especially for functions. Okay, and even the subsequent chapters. All right. So why I just straight away write 5 over 4? Because 5 over 2 divided by 2 is 5 over 2 times 1 over 2. So 2 times 2 is 4. That is 5 over 4. Okay? So I hope you can understand about this. Okay? So you may factorize in this form. Yeah. So here is your answer of the gfx in the vertex form. Okay? Where these three are constants and real numbers. Okay? Well, let's proceed to the next question. This is the question 12. So this is a 9709, October, November 2024, 2004, question 9, paper 1. The function f maps to the x to get 2x minus a, where a is a constant, is defined for all real x. Okay, so let's rewrite the function f into the expression with equal sign, which is fx equals to 2x minus a. Okay, where a is a constant as long your domains are all real numbers. Okay, you will spot that actually this function f is a linear function. Okay, so let's take a look at the first part. Okay, for the first part, in the case when a equals to 3, solve the equation f of x equals to 11. Okay, so you will see that here is your composite function of the f. Okay, where the function f maps to its domain. Okay, to get this composite function. So for the first part, substitute a as 3, so means that for the first part, your fx will be 2x minus 3, particularly. Okay, and next you need to find the f(x) first. Okay, let's looking for f(x). So substitute the fx as 2x minus 3. Okay, you map your fx inside itself. Okay, so you will see that you will get 2 times 2x minus 3 and then minus 3. So in the end you will get 4x minus 9. Okay, for the f(x). Next, you follow the equation above. Okay, f(x) equals to 11, and then you may solve it. So your final answer should be 5. Alright? Okay, let's take a look at the next part. On the next part, the function g maps to the x to get x squared minus 6x is defined for all real x. Okay, so for the same thing, I need to rewrite again. So your gx equals to x squared minus 6x, for which x are all real numbers. Okay, as long as the domains are also all real numbers. So what will you spot? You will spot that function g is a quadratic function. Meanwhile, your function f is a linear function. Just that this question wants you to find the value of a. So it means that the value of a is no longer 3. So your fx generally is 2x minus a right now. Okay? So the question wants you to find the value of a for which the equation fx equals to gx has exactly one real solution. Okay? So, just like what I said just now, gx is a quadratic function, whereas fx is a linear function. In the end, you follow the equation, you will simplify into the quadratic equation, but equals to 0. And then you will see that there's a keyword of exactly one real solution. What does it mean? Means that this quadratic equation has a discriminant b squared minus 4ac equals to 0. Okay, so when you're solving this type of question, you need to figure out what does the question aim to ask. Okay, aim to ask you to solve it out. Okay, so you must need to be smart. Okay, emphasize all the keywords from the questions and then figure out what does the examiner want you to solve it. Okay, so use this property after you obtain the quadratic equation from this equation. So I don't think I have enough space. I need to create new page. Alright, for me to convenient to do the last two parts for this question. So now you equate gx to fx. X squared minus 6x equals to 2x minus a. Now you simplify the into quadratic equation as I said just now. Alright, use the property of the discriminant b squared minus 4ac because it says that this equation, when you simplify into the quadratic expression, the quadratic equation that equals to 0, only has exactly one real solution. Okay, substitute all your ABC, the coefficient and constants from the quadratic equation, and next you find the a, the value of a. Okay, just use your calculator, and then you will get the a as 16. Okay, so I may proceed to the third part. The function hx equals to x squared minus 6x is defined for the domain x is greater or equal to 3. Okay, so for this question, I will rewrite the function h as well. So you can see that the function hx is exactly the same as the gx, just that their domain are different. Their domains are different. Okay? So for the third part, I think this for the A-level pure maths students, you have used to it. This is my assumptions. So in the third part, you just need to use the CTS method. Enough. Okay? So that's why I said CTS is very crucial in solving the function. Okay? In solving the passive questions from the functions. Okay? So how to express x squared minus 6x into the vertex form? Add bracket square of b over 2. Okay? So what is your b right now over here? It's negative 6. Okay? So plus negative 6 over 2 and minus. Okay? Simplify over here. You will get x minus 3 square and minus 9. Okay? So that's the vertex form of the hx. Okay? Now, for the fourth part, find an expression of the inverse hx and state the domain of the hx. Okay, so now, here is the tutorial how to find the inverse of the quadratic function. But you need to convert to vertex form just before you carry out the inverse process. Okay, so let your hx as a y. Okay, first step, let your function into y first. Next, change the subject to let the x become the left hand side, meanwhile in terms of y. Alright? Basically, you need to express your x in terms of y. Okay, just carry out the reverse process. So I have y plus 9 plus or minus square root and plus 3. Okay? Next, you will see that you have the plus or minus square root of y plus 9 because of this is a quadratic equation in vertex form. Okay, fundamentally it has two roots. So you need to divide into two scenarios. Alright, provided that x must be at least 3. Okay? So, what is the value of h3? Okay? You can calculate and see, because we need to verify whether this inverse function lies back to the domain of the hx or not. Okay? And whereas for this y is the range of the function h. So the h3 is negative 9. So now you may try to substitute negative 9 over here, but this is not possible because when you substitute the 9 inside here, both square root will be get 0. You can't verify any difference. Instead, we can use h4. Okay, so try substitute x as a 4 inside the function h, negative 8. Now you may try to substitute a y equals to 8 inside its equation. So see what value you get. Okay. So for the positive scenario, you will get 4. Okay. Which lies inside the domain already. Okay. Next, you substitute for the negative 1, you will get 2. So you will see that for the negative scenario, x equals to 2 does not meet the domain. Okay, means that for the negative, each domain, I mean the each range for the inverse hx, if it is a negative scenario, doesn't, okay, each domain doesn't meet the requirement. Okay, means that the range of the inverse hx for the negative scenario doesn't lies meet the requirement of the domain. So so the only answer is the positive scenario. So you need to rewrite the expression of the inverse hx, which is the square root of x plus 9 plus 3. Okay? So where x is greater or equal to negative 9. Okay? And for the fourth question, it wants you to state the domain of the hx. Yeah, I've stated over here. Okay? So that's the answer for the fourth part. Okay? Huh. I must indicate that here is the domain of the inverse h. Okay? So that's all for this question. Let's move on to the next question, which is question 13. So this question is also from the past year questions 9709, May June 2016, question 11, paper 1. Okay, functions f and g are defined by f maps to x to get k minus x for x subsets all real numbers where k is a constant, whereas g maps to x to get 9 over x plus 2 for x are all real numbers provided that x is not equal to 2. Okay, so actually these statements make sense if you because when you substitute negative 2 inside the domain, you will that means this entire function is indefinite because you can't divide by 0. Okay, so for the first part, find the values of k for which the equation fx equals to gx has two equal roots and solve the equation fx equals to gx in this case. Okay, so let's begin from the first part. So given that function f to the x equals to k minus x, so this is a linear function, whereas for g, it is likely a reciprocal function. But why does the question mention that this equation has two equal roots? Okay, so let's discover right now. So firstly, you need to equate fx to gx first. Okay, write out all the expression of the functions. Okay, next, multiply the term x plus 2 at both sides of the equation. So what will you spot? You will spot that you can form a quadratic equation. Okay, next, expand and simplify it. Okay, so this is what you get after you expand and simplify into this quadratic equation that equals to 0. Okay, so what does the two equal roots mean? It means the discriminant of this quadratic equation b squared minus 4ac equals to 0, because this quadratic equation, when you visualize in the graph, it says that your quadratic parabola curve only touches the x-axis by 1 point only. Okay, so substitute all the ABC inside this discriminant. Next, you expand and simplify to get the quadratic equation in terms of k. Okay, so you have 4, k squared minus 4k plus 4, 36, and 8k. Okay, now, now you will see that this equation is obviously can be factorized obviously. Okay, next, factorize it properly. Okay, 8 times 4 is 32, and plus 8 minus 4 to get plus 4. Okay, minus 4 times 8 to get negative 32. So write out the values of the k. So you will get the k as 4 and negative 8. Okay, you will see that you have two answers of the k, which is 4 and negative 8. And also you may see that given that the question wants you to find the values of k, okay, you will see this plural values means that the answer of k is not only 1 but 2. How do I know the answer is 2? Because this expression, when explained and simplified, you will get a quadratic equation because the highest power goes to 2. Okay? So once you find the value of k, the question also wants you to solve the equation fx equals to gx in these cases. Okay? So what does these cases refer to? It refers two cases of the k. Okay? So let's separate into two cases to solve the equation. So for the case when k equals to 4, most of you will substitute a k inside here, then you are going to re-expand again. But I not recommend you to do this. Instead, you can direct substitute your k inside this quadratic equation that equals to 0. Alright? So 2 minus 4 is negative 2. Okay, I may write the full workings for the full guidance for understanding. Okay, so this is what you get. You have x squared minus 2x and also 1. So you see that this this quadratic equation is of course can be factorized into the square form. Okay, so it is completing the square to factorize it. Alright, since you use the property of b squared minus 4ac to get 0, means that your x over here only has only 1. Alright, following its discriminant properties. I mean the properties of the nature of the roots. So you may factorize into x minus 1 squared. Okay, so for the case when k equals to 4, the solution of this equation of the equation gx equals to fx to get 1. Okay, this is one of the answer. And don't forget to solve the another case. So for the case when k equals to 8, next you substitute the 8 inside. Next, evaluate these two coefficient and constant to get here you get plus 10. Here you get plus 7. Wait a second. Okay. Sorry, here is 25. Okay. So after you factorize, okay, so this quadratic equation is also the completing the square. Okay, I mean completed the square to factorize. So you will get x plus 5. Okay. Eventually the value of the solution of for the case where k equals to 8 is negative 5. So eventually the solution of the two equations, that is x equals to 1 for k equals to 4, x equals to 5 when k equals to -8. Alright, that's the end of the first part of the questions. Okay, let's move on to the next question. For part 2, solve the equation f g x equals to 5 when k equals to 6. Alright, so for the second part, the value of k is no longer 4 and -8. Okay, or I can rephrase my sentence as, for the second part, the k equals to 6 instead of 4 and -8. Okay, so you can also see that here is a fgx. Okay, fgx is a composite function, maps to the, let the g maps to the x first, just before for the f maps to the gx. Okay, to get this composite function before equate to 5. Alright, so let's rewrite the function f first. Okay, because since your k is 6 for this part, so that means your fx is 6 minus x, correct? And also your gx is still equals to x plus 2. Alright, next we find the composite function fgx. Okay, map the gx first. Okay, let the g maps to x first, then the function f maps to the gx. Right, so do it this way. So we'll see that this is a reciprocal function. But to make me more convenient to solve the equation, I have to multiply x plus 2 at the both sides for here. Okay, for the numerator and denominator sides. So I have 6x, 6 times 2 is 12, 12 minus 9, that is 3, right? Okay, okay, once you obtain the fgx, equate the fgx to 5. Alright, based on according to the questions. And next you expand it, multiply x plus 2 at both sides and expand it to get 5x plus 10. Alright, the simple mathematical workings, and finally you get the x as 7. Alright, okay, next for the third part. For the part 3, express g inverse x in terms of x. Okay, so for this question is quite easy because the third part only focuses the gx only. Alright, and find the inverse right now. To find the inverse, you need to let gx equals to y. Okay, you can also let the gx equals to any constant as long this method is valid and also it works. So for my method, my suggested method, you may substitute the gx by y first. Okay, now you switch the subject from y to x to let x in terms of find the x in terms of y. Okay, that means you let your x as a subject. Okay, so to do this, swap the positions of this, and then move the plus 2 to the another side to get x equals to 9 over y and then minus 2. Alright? And don't forget to rewrite again. Because many of students made this kind of the careless mistake because they forgot to convert this into the inverse form. Alright? So yeah, here is your final answer. And also provided that x is not equal to 0. Okay, to define this function. Okay, so that's the end of this discussion for this question. Let's move on to the next question, which is question 14, is also from past year questions. Okay, this past year question is 9709, October November 2007, question 11, paper 1. The function f is defined as f maps to x to get 2x squared minus 8x plus 11 for x subsets all real numbers. For the first part, express fx in the form of vertex form where a, b, c are constants. Okay, so what are you going to do? Rewrite the function x where fx equals to 2x squared minus 8x plus 11. Next, you must use the completing the square method to get the vertex form. Okay. Okay, so here is your fx in the vertex form. Okay, let's take a look at the second part. State the range of f. Okay, so this is the quadratic function. Okay, imagine when this quadratic function is sketched in the Cartesian plane. Okay, you will see that the a is positive. Alright, means that this quadratic, the parabolic curve has a minimum point. Okay, where the minimum point is 2, -3. And what is the range? The range is the interval from the domain. Alright? Okay, which is defined from the domain. Alright? So that means the range of the f is greater or equal to 3, or at least 3, -3. Sorry. Okay, this interval above. Alright? So let's take a look at the third part. Explain why f does not have an inverse. Okay. So what is the condition for inverse function? Okay, the condition of inverse function is 1-to-1 function. Okay, what is function? Okay, function is a relation that consists of 1-to-1, okay, many to 1. So means that the function f, it is a many to 1 function, right? There's another answer, that is using a horizontal line test. It intersects 2 points with the graph. Right? That's all for this question. No need to write too long. Okay? But you need to write the keyword of many to 1 intersects 2 points. Alright? Regardless how good is your grammar. Okay, you must let the examiner to be seen that you've written these two keywords, any these keywords inside this question, right? So yeah, the function g is defined by g maps to x to get 2x squared minus 8x plus 11 for x is at most a, where a is a constant. State the largest value of A for which G has an inverse. Okay, just like what I said just now, what is inverse? Inverse means that when you carry out the horizontal line test, it only intersects one point with the graph. That means you need to sacrifice the half of its domain in order to let it to has an inverse following the interval of the domain. Okay, so for the quadratic function, we need to find out where is the axis of symmetry. Okay, so following this minimum point, following this vertex form, you'll spot that there is an axis of symmetry where the x coordinate is 2. So means that x is at most 2 in order for gx to be has inverse. Okay? Therefore, your A is 2. That's all. Alright? Okay, let's move on to the last part of the questions of this question. When A has this value, obtain an expression in terms of x for g inverse x and state the range of the inverse gx. So, to find the inverse function for my suggested method, my suggested solution, I need to replace gx or substitute gx as y first. Okay? For me to easier to carry out the completing the square. And wait, if you aware that the function f is exactly the same as the function gx, just that their domains are different in particular cases. Alright, so let the gx equals to y. Next, place the y equals to 2x, this vertex form. Alright, and then you let the x as a subject in terms of y. So you will obtain this. Okay, separate into two cases. So, what is the y? The y means the range. Okay, so what is the range? Okay, so you will see that there's a range of fx is at least negative 3. So for me, I will suggest an example value of the y to test whether which of these two functions, okay, which one of these two functions obeys meets this requirement. All right. When any of it has this domain, right? So let's try y equals to negative 2 inside here. So for the left hand side, I put negative 2 inside here. Okay, so I will get 1 over 2 plus 2. Meanwhile, for the another side, I have negative 1 over 2 plus 2. Okay, so you need to use your calculator to calculate the approximate decimal value, because since there is a third form over here, square root form. Okay, so obviously after you calculate its decimal value, obviously you will see that for the left hand side, the range of the inverse gx, of course, is greater than 2 already. Alright? Meanwhile, you will see over here, when your 2 minus of this must be greater than 1. Okay? So means that this is less than 2. Therefore, for the negative side, it is accepted. Okay, because its range, the range of this lies in the domain of the gx. Alright? This is what am I trying to explain. So you need to rewrite what is the G inverse X. Okay, what is G inverse X? It is negative x plus 3 over 2 and plus 2. And hence you need to state the range of the G inverse X. As I said just now, as the range of the G inverse X meets the domain of the Gx, therefore, the range of the G inverse X is literally domain of the Gx, right? So therefore, the range of the G inverse, that is G inverse X less than or equal to 2. That's all for this question. Alright, let's move on to the next question, which is the question 15. Okay, question 15 is also from the past year questions. This past year questions is 9709, October, November 2010, question 7 and paper 1-2. The function f is defined by fx equals to x squared minus 4x plus 7 for x is greater than 2. Express fx in the vertex form and hence state the range of the f. Okay, so this function f is a quadratic function. You need to express this the general form to the vertex form. Okay, so just carry out the completing the square by add bracket square of b over 2 plus and minus. Okay, so since the coefficient of x squared is 1, so means that it makes you easier to carry out this process. Alright? Okay, so here is the fx in the vertex form and hence state the range of the f. Okay, so C, here is positive, so smiley face in the parabola curve means that it has a minimum point, so means that the range must be greater or equal to the y coordinate of this minimum point. Alright, so you can write range of the function, that is fx is greater or equal to 3. That's all. Okay? Second part, obtain an expression for x inverse x and state the domain of the f inverse. Okay, let's deal with this part first. Okay, as always, let the y equals to fx before carrying out the inverse process. Okay, so you have plus or minus of y minus 3 and also plus 2. Alright, and next, divided into two cases. Next, check the range of the fx over here. Okay, carry forward to substitute inside. So for me, I will give an example. Let me test y equals to 4 over here. Okay, so for the first, so let's assume here is the first, here is the second, means that we have two cases over here. Alright, so for the first one, you will get 1. For the second one, you will get 3. So, what is the minimum? What is the domain? What is the domain of the f function f is greater than 2? Okay, so as you can see that for the second one, it exceeds 2, whereas for another side, it does not exceed. So means that for the x1, it is not acceptable for the negative negative cases. So means that we need to take this as our inverse function. Alright. So therefore, your inverse fx will be the square root of x minus 3 plus 2. Okay, after you have carried out the inverse process, don't forget to convert back this into inverse form, and also here x. Okay, don't do this careless mistake. Alright, be aware. And now state the domain of the F inverse. Okay, domain of the F inverse is literally equal to this one. Alright, so the domain of the F inverse will be x greater or equal to 3. That's all. Okay? Alright, let's take a look in the next part. Function g is defined by gx equals to x minus 2 for x is greater than 2. This is a linear function. The function h is such that function f equals to function hg. Okay, you will see that hg is a composite function and the domain of h is x greater or equal x is greater than 0. For the third part, obtain an expression for hx. Okay, let's rewrite over here. Based on according to the questions, you will obtain that gx equals to x minus 2, fx equals to hgx. Right? So, how to get the hx? So, you must substitute the x as g inverse x in order to get back hx. Okay? So, yeah, it makes sense. If you still can't understand, let me repeat this again. Okay? fx equals to hgx. Okay? As you know that the function to the function of inverse of x, you will get x. Okay? This is the property that you need to know and memorize it. Alright? So even imagine there's a mapping diagram. When you function it into here and you carry out back, when you composite function, and here is your x, and here is your fx, right? When you are doing the composite function of these two, okay, you carry out the forward and backward process, means that you didn't function anything. You still get back x. Alright? So this is the inverse but composite function. So you need to substitute the x as g inverse x just before you get back this one. So basically hx equals to f of the inverse gx. Okay? If you agree, please comment in the comment section below. Alright? So let's obtain what is the inverse gx. Oh, actually it is easy lah. G inverse x is y plus 2. Alright? So what is your fx over here? Okay, your fx is x minus 2 square plus 3. I'm sorry, my mistake. Here you should put x because you need to say inverse of gx must in terms of x. Okay, substitute inside, so means that you need to function to x plus 2. Okay, and also here you have x plus 2 minus 2 square plus 3. Now you simplify it. Eventually you will get x squared plus 3 for the function for the hx. That's all for this question. Okay, let's proceed to the last question for the exercises for chapter 2, which is the question 16. Okay, question 16 is a past year questions as well. And this is the 9709 October November 2008 question 10. Of course it is paper 1 because this is the pure mathematics 1. Okay, in this system. So let's begin. The function f is defined as f max to x to get 3x minus 2 for x subsets all real numbers. So for this question, it should be easier for you to sketch this linear function graphs. Okay, because for the first part it asks you to sketch in the single diagram the graphs of y equals to fx and y equals to inverse fx. Make clear the relationship between the two graphs. Okay, so please highlight this. Please highlight these keywords and sketch in a single diagram. Okay, if you sketch in the separated diagram, although these marks are still allocated, but you won't get full marks because you didn't follow the requirements of the question. All right, so fx equals to 3x minus 2 means that f inverse x will be x plus 2 over 3. Agree? So if you separate it into the gradient form, you will get 1 over 3 x plus 2 over 3. Okay? So means that both functions are linear functions. Okay? Now you may sketch in a single diagram. I may change the color first. So here is a y and x. How to sketch the linear function? First, y-intercept minus 2, maybe over here, and 2 over 3. Okay, what is the x-intercept when fx equals to 0? It is 2 over 3, right? So how to draw 2 over 3? It is approximately 0.666 or something. Okay, so here is your 2 over 3. And you will see that its gradient is positive. So just draw a straight line over here. I may shrink it a bit. Okay, this is how does the function f look like in the Cartesian plane. Okay, and also for the function f, its x coordinate numerically equals to the y coordinate. Okay, so if you are in the inverse function, the x coordinate of the function f is numerically equal to its y-intercept of the inverse function. So means that you need to draw over here -2. Okay, basically the gradient is reciprocal, as you can see over here, but their gradients are still positive. So I may draw here approximately, and also the -2. So this is how does the graph look like. And the question also wants you to make clear the relationship between the function f, function fx. All right. So that means you need to draw a line y equals to x. Okay. Of course, it's not a solid line, but by borderline. Okay. To make clear the relationship between the fx and f inverse x. So, after you have drawn the graph y equals to fx and y equals to inverse fx, it's time for us to make clear the relationship by draw a borderline y equals to x. So what does it mean? It means that any coordinate from here, its x coordinate and y coordinate will swap after it converts into inverse fx. Okay, so that's the declaration. That's the question 1. All right, so let's proceed to the next part, which is part 2. Express g of x in terms of x, hence show that minimum value of g of x is 9. Okay, what is what is maximum value? Okay, maximum value is the y coordinate of the turning point. Okay, so why does it mention maximum? It means that the coefficient of x squared is negative, means that its graph is a set face in a parabolic curve. Set face parabolic curve in the Cartesian plane. So given that the gx is defined by where g maps to x to get 6x minus x squared for x subtext all real numbers. Okay, let's rewrite gx equals to 6x minus x squared. So after you composite the function, after you find out the composite function g of x is of course the quadratic function, since the gx is quadratic function. Alright? So generally, fx is a linear function, function g is a quadratic function, so all in total, its highest power goes to 2, therefore, composite function g of x is a quadratic function. Okay? So yeah, it makes sense. So let's find out the g of x first. What is the fx? It's 3 minus 2. Next your function g, you map 3x minus 2 by g, function g inside this function. Alright, so expand and simplify it. So here I have 18x 12 negative 9x squared positive 12x and negative 4. And then rewrite in the general form before convert to vertex form. For you to easier to work out whether the maximum value is 9 or not. Just do the verification by workings. Okay. Next, you need to factorize it. Alright, so this is what you obtain of the gfx in the vertex form. So take a look over here. Okay, so now we can state the range of the gfx, which is okay, since the coefficient of the x squared is negative, therefore it has a maximum value which is until 9 only. Alright, therefore shown. Okay, so you need to find out the GFX. Next, you convert into vertex form to show that you have successfully worked out the GFX has a maximum value of 9. Okay? Alright, let's take a look at the last part over here. Function h is defined by h maps to x to get 6x minus x squared, but it is exactly the same as the function gx, just that the domain this time is at least 3. Okay? Now, for the third part, express 6x minus x squared into the vertex form. Okay, where a and b are positive constants. So, factorize the negative first before adding the bracket square of the b over 2. Okay, do it this way. So there you go. The answer for the third part in the vertex form, which is negative bracket square x minus 3 plus 9. But it wants this form. So what about rewrite the form into 9 minus bracket square x minus 3. That's all. Okay. So let's take a look at the next part. Express h inverse x in terms of x. So as always, I will let y equals to h inverse x first. Then I convert to x as subject in terms of y. So I have 9 minus y plus or minus and also plus 3. Okay, divided into two cases. And then the y. Y refers to the range of the hx. So what is the range of the hx? Okay, figure out by yourself. I'm not going to repeat this again. I'm not going to repeat the same method again, which is hx is greater than or equal to 9. No, it has a maximum point, so it means that hx is only until 9 only. Right? So what about we substitute y equals to 8 this time? So if you try y equals to 8 over here, you should get 4 for this. And meanwhile here is 2. Now check out the domain. What is the domain? Domain says that the x is at least 3. Okay? So which of two of this range of the inverse lies the domain of the hx? Obviously of course it's this one. Okay? So it means that for the negative cases it is rejected because of when you try the y equals to 8 inside, it gets back 2. It gets 2 but less than 3. So it is totally not acceptable. Only this will be accepted. Okay, so therefore you need to rewrite what is the inverse hx, which is the square root of 9 minus x plus 3. That's the final answer. Okay, so here is the end of the discussion for the exercises of this entire chapter 2. Thank you. Thank you for watching this video. Be sure to like and share this video and subscribe to this channel. I will see you in the next video. Goodbye.